So for this lecture, we're going to look at network traffic, particularly traffic shaping, and how to control bandwidth utilization, how to reduce bottlenecks, basically quality of service, and type or class of service. So let's go ahead and look at the desktop. All right, so network trafficking. Traffic shaping or packet shaping is a bandwidth management technique trying desperately to control the flow of network traffic and to eliminate bottlenecking, to eliminate as many collisions as possible. Essentially what you're trying to do is make the traffic more efficient. Higher priority of traffic, or rather the flow of high priority traffic over the flow of low priority. So if you got low priority traffic, things like YouTube, streaming, things like that, versus high priority traffic, which is applications specific to your company, you want those traffics to have the priority. So quality of service prioritizes traffic of resource intensive applications at layer 3. Basically, this would be where you would set priorities for applications. And then class of service prioritizes traffic of resource intensive applications at layer 2. Priority is traffic by group, allocating different levels of priority to different groups. So you could assign higher priority to voice over IP versus web page traffic. So there are two different types of traffic shaping, quality and class of service. Don't forget to do the participation activities. VPN traffic modes, split tunnel versus full tunnel. A VPN, or virtual private network, is one type of tunneling protocol. It's very easy to use, and that's why there's used so often versus other tunneling solutions. Two types or two modes exist. A full tunnel routes and encrypts all network traffic through the VPN regardless of where it's hosted. Full tunnel is generally recommended. It's more secure because all the network traffic is encrypted. Full tunnel is a better option to handle confidential data, where split tunneling may be necessary to access internet and office resources. But split tunneling is less secure. A split tunnel routes and encrypts all non-internet traffic over the VPN. Traffic going to websites, if you're going to Yahoo, if you're going to YouTube, if you're watching videos, if you're streaming, if you're checking email, which the email should be encrypted, but the process of checking them is not. Those websites are bypassed through the VPN, and they're just basically accessed just like they would be without the VPN. So full tunnel, everything's encrypted. Split tunnel, only the office network traffic, server traffic specifically for the office, gets encrypted. If you're going to YouTube while you're working on a office application, the YouTube traffic is not encrypted. Process of split tunneling allows routing of some device or app traffic through an encrypted VPN while the other devices go to the internet directly. It can be used to protect confidential data without losing access to local network devices. More participation activities. Loop prevention. A network loop, or a layer 2 loop, or a bridge loop is a network topology in which more than one path exists between two networked endpoints. A network loop occurs at layer 2. That's the data link layer. A loop exists if more than one path exists between two hosts on a LAN. So if you've got multiple servers on a LAN or multiple nodes on a LAN, and the logical pathways are there for packets to go to both of them through different routes, that would be a loop. Since a switch forwards broadcasts and multicast to every switch port, a loop causes the switch to repeatedly rebroadcast, broadcast and multicast packets. You can end up with a broadcast storm. So the switch starts sending out broadcasts for, say, an ARP request, and because it's going around in a loop, it's having some traffic returned. Large number of broadcast and multicast packets on a network within a short amount of time, and as it builds up, then it bogs the network down. So a network loop degrades network performance by exhausting the network bandwidth. It just eats it up. Broadcast storm prevention or storm control is the act of preventing or reducing packet rebroadcasts on a LAN. Broadcast storm control prevention methods include the removal of loops by disabling the ports and limiting the rate of broadcast traffic. Once again, more participation activities. Oops. Broadcast packet data unit is a packet exchange between switches on a LAN to detect the network's loops. This is how you would set up loop control. Loop removal is you have to find them first, and they're not always apparent. An attacker can use a switch port to inject these malicious bridge protocol packets and basically drown a network and shut the network down, because he's injecting these packets that don't get filtered out, and they just keep going and build up a storm. Bridge protocol data unit guard is a control mechanism for preventing this sort of thing from happening. It protects a layer 2 STP topology from this bridge protocol data unit attack. Spanning tree protocol. Network topology often resembles a tree with a central node acting as a trunk, and other nodes connect to the trunk as branches and leaves. Spanning tree protocol STP is a network protocol layer 2 device used to eliminate loops. It eliminates existing loops in a network tree. It reconfigures a network tree whenever a network change occurs, so that it continues to prevent loops. And it increases a network's tree's fault tolerance. That's its ability to absorb and compensate for disconnects. STP convergence time is kind of slow. Changing a switch port from blocking to forwarding results in a 30 to 50 second convergence time. Rapid spanning tree protocol is a network loop eliminating network protocol with a faster convergence time than STPs. RSTP's convergence time is less than 10 seconds. IEEE standardized it as IEEE 8021D and RSTP as IEEE 8021W. RSTP is backward compatible with plain old STP. All right, there's your challenge activity. Once you have this all completed, then you can move on to the next section, which will be 7.3. Okay, guys, that's the section 7.2, network traffic. If you have any questions, let me know via the Canvas inbox or contact me in class. I'll do my best to answer.